All right, good morning. Hope everyone's doing well. Today we are going to learn about the Pythagorean Theorem. Okay, this is going to end our Unit 6. So we're going to do Pythagorean Theorem today, which is Monday, April 20th. We'll do some application, more application on Wednesday, and then Friday, what we'll do is we'll take an assessment over Unit 6. That's kind of what our plan is. So we'll see kind of where we end up. If you guys have questions, there'll be a Zoom meeting today at 2 p.m. That I'll be able to come on, answer any questions you have, and kind of go through. So what is the Pythagorean Theorem? I'm trying to get rid of some glare here. Pythagorean Theorem is a formula we can use to help us find missing sides of a triangle, specifically a right triangle. So in a right triangle, and this is a generic right triangle, we would have three sides, obviously a right angle, and we would classify the sides as A, B, and C. Now, A and B don't matter what order you put A and B, they're considered legs. And the reason why we consider them legs is they're not across from the right angle. They're not the longest side. They're smaller sides. Our longest side is C, the hypotenuse. Had to think about spelling that one, but I think I got it right. Is the hypotenuse. And that is always directly across from the right angle. I'll give you another kind of look of a triangle. If you had your right angle in the upper right-hand corner, C is directly across. C is always directly across. And then we have A and B as our two legs. So this is another type of right triangle we can use. What the theorem states is that if we take side A and side B, we add the squares of those together, they would be equivalent to side C squared. So the formula is A squared plus B squared equals C squared. And this is the formula we use to find any missing sides. Okay, so for today, we're going to go ahead and have a triangle. This is our example problem. We have our triangle. We are trying to find the hypotenuse. We have 3 and 4 as the lengths of our triangle. So because we have A and B, and we're going to solve for C, we substitute the information we have into our formula. So we have 3 squared plus 4 squared equals C squared. And we go ahead and solve for C, just like we would any equation that we have. We need to simplify, we need to isolate, and we need to do anything we can to undo what's happening to our variable. So 3 squared is 9, 4 squared is 16, and that is equivalent to C squared. We can still add 16 and 9, which is 25 equals C squared. Now, this is where I would think most of us will get stuck and say, well, what do I do here? We need to undo a square. And last unit, we talked about what we needed to do. Sorry, this unit, the first half of this unit, how do we undo a square? What's the opposite of squaring something? Well, the opposite of squaring something is square rooting it. So we are actually going to take this equation and square root both sides. We square root 25, we square root C squared. And what that happens here, when we square root a square, we end with just C. The square root of 25 is 5. Now, Because we don't know what C is, we actually end up with an answer of positive and negative 5. That's what the symbol is here. It means plus or minus 5. In this equation, C can either be positive 5 or negative 5. Okay, because negative 5 times negative 5 is 25, and 5 times 5 is 25. However, because we're talking about geometry and we're talking about distance and length of a side, we can't have a negative length. So our answer for C will be 5. However, we need to account for that negative because sometimes we do need to use this. For geometry's sake, for the sake of this unit, for what we're going to use it for, usually the negative answer is not applicable. However, we always need to write it, think about it. Is this something we can use? Because a lot of times negative answers are answers we need. Hope you guys are having a good day. And that's Pythagorean Theorem.